In this lesson, we're going to be using the idea of solutions to draw connections between graphs and tables and functions. So the first question is, what are solutions? Solutions are values that when substituted into an equation make it true. So again, we'll use these ideas of solutions and let's make some connections here. So these are things that you've seen before. In each for this equation here, we're asking, is each value a solution to this equation? So we're going to start with this equation for each of the values. And basically, if we're testing to see if it's a solution, we're really testing to see if, when substituted in, it makes the equation true. So I'm just going to substitute each of these values into each equation really quick. And again, now we're just going to simplify down and see, does it make it true? If it makes it true, then the value is a solution. If it does not make it true, it's not a solution. So I'm just going to simplify them down really quick. So on the first one, we're 0. When I substitute 0 in, I get 1 equals 6. 1 does not equal 6, so we would say that 0 is not a solution. And it's not a solution to that specific equation. So I think that's important to consider, that it's not a solution to that equation. It could be a solution to another equation if given that. The second one, 6, when we substitute 6 in, we get negative 12 plus 1. That's negative 11 equals 6. And again, we'd say that 6 is not a solution. Very, very similar to 0. Now the next one, if we substitute that in, we end up with, looks like 5 plus 1. 6 equals 6. 6 does equal 6, so we would say that negative 5 halves is a solution, right? It does make it true. And so just testing the other ones here, we get 5 equals 6. 5 does not equal 6, so negative 2 is not a solution. So we're going to use this idea of solutions, and we're going to start expanding on it. So these were very basic. If you notice, this equation had one variable, just had the x, and we're just testing one value in it to see if it's a solution or not a solution. If it makes it true, it's a solution. If it does not make it true, it is not a solution. And remember, negative 5 halves was the solution. Now this looks a little bit more complicated. Now we're given coordinate pairs. So we have an x and a y value. And then we also have this equation. So we're talking about, is it a solution to this? So the idea of solution, again, when we substitute the values in, it makes it true. So I'm going to start with this equation on each of these. Now on the previous type of equation, you had one solution. There was only one value that would make that true. Now that we have multiple variables, there are actually multiple combinations that might make this true. So if we're testing to see if it's a solution, we're just going to substitute the appropriate one. So 4 is the x value, so it's going to go in for x. And then 6 is going to go in for y, and we're going to see if it makes it true. So all I did was substitute 4 in for x, 6 in for y, and see, simplifying down, it does make it true. So we would say that 4, 6 is a solution, aka 4, 6 makes it true. Now substituting the next one, negative 5 goes in for x, negative 3 goes in for y, and I simplify it down. I get negative 3 is equal to negative 3. So we would say that the combination negative 5, negative 3 is a solution as well. Continuing on, I'll just go ahead and show the work for the next 3. Maybe at this point you hit pause and you try each of these problems, and then when you are finished with them, you hit play to resume. So as I substituted these values in, I found that 5, negative 7 is not a solution, did not make it true when I substituted those in. 0, 2 was a solution, it made it true. And then 0, 4 was not a solution. So we see that 0, 2 is a solution, 4, 6 is a solution, negative 5, negative 3 was a solution. So we had multiple combinations, multiple x and y values that would make this true. So let's look at and start drawing some connections from this. These are 3 functions. And basically what we can do here is we can graph the solutions. We can graph the points that make each of these true. So we don't have the equations yet, but we can actually just identify solutions from these. So looking at the first one, one solution that I see, one value that's on this graph is 0, 1. So I'm just going to complete the table here. Another one that I see is this point right here, which is 1, 2. I see here is 2, 5. And looks like right here is 3, 10. I could have also chosen points on the other side of the parabola here, other side of the quadratic. These would be possibilities. But again, every point that's on this graph of the function represents a solution to the equation that's going to be given. So go ahead and hit pause and then identify solutions on the next two. Play when you resume and when you're finished. As you're looking these over, your points that you listed may not be the exact same points that I listed. You could list any point that is on an exact coordinate here that would actually make that true. So when we're talking about solutions, we graph the solutions. On the exponential function to the right, we want to be really, really careful because remember this is an asymptote here where it gets really close. So although it appears that it is on that line, it actually is not. So remembering what that asymptote is will help us identify these solutions. Again, any solution is going to be a point that is represented on the graph. Let's look a little bit more clearly at and focus in a little bit more on linear functions here. So if we're looking for solutions, remember the solutions are graphed on here. So I see here like 0, 5 is a solution. I see an exact coordinate 2, 9 is a solution. I see a point -2, 1 and looks like -3, -1. Now, a point that I really, really want to stress here is that this is a line. So there are solutions and combinations of x and y's, an infinite number of these, in fact, all along here. So right now we are actually just listing ones for simplicity's sake that are on exact coordinates. However, there are fraction and decimal coordinate pairs all along here that are going to make that true. So although we're just listing a handful here, and the handful that we've selected are on the coordinate, on exact coordinates, there are solutions throughout this, so values that again would make this true. Now, this is the connection that we really want to draw. Now we have a graph, we have an equation that has x's and y's, and we have a table. If we look at the equation, we can find different combinations of x and y that make this true. So the first thing I want you to do is I want you to think about this equation and think about a combination, a value for x, a value for y, that when you substitute it in makes it true. And I want you to fill in some of those on the table. One combination that I saw was, if x is 5 and y is 2, that makes it true. And then I thought, like, if x is 0, then y has to be -3 if I substitute those two values in. If x was -2, y could be -5. And if I substitute in, say, -1, then y would be -4. So again, make these values that make it true. Now, here's the connection that we want to see. So we listed values that make it true, which are solutions. So basically, this table is solutions. These are all solutions to this equation. They're all values that make it true, combinations of x's and y's that make it true. Now, since there are multiple values, and since there is actually an infinite number of value combinations that would make this true, this is what we graph. So we graph the solutions. So here was 5, 2, the first point. Here was 0, -3, -2, -5 was down here, and then -1, -4 was right here. So I've just graphed the solutions from the table that I found from the equation. So really what we see here is that the table represents the solutions. It organizes the solutions from our equation, and then we graph the solutions on a graph. And remember, there are solutions that are all along here, there's an infinite number of combinations of x's and y's that actually make that true. So that's why we have the line here. So the table represents the solutions. We graph the solutions on a graph, the combination, of just these points, these xy coordinates. And so this really is the solutions to this equation. It's just the combinations of x's and y's that are going to make it true. And that's the connection we want to draw here, is the table and the graph and the equation are all related to solutions here. So really quick, try these on your own. I want you to just find x's and y's that are the combinations that make this true. So fill in your table first with solutions, and then graph those solutions. And when you're finished with that, go ahead and hit play. So hit pause, complete these, hit play, check for feedback, see if your graph is the same graph that I have. As you're checking these, a few things to point out. Your table most likely is not the exact same table that I have. And that's okay. But what should be the same is your graph and the location of where your line is going. So when we look at this first one, your graph should be in the same relative location. And on the second one, again, it should be in the same relative location. You should be using a straight edge. I did not have one handy here. That's why mine looks a little bit different. So when we look at this, really what we're talking about is the solutions. We're graphing the solutions to each of these unique functions. And these are both linear functions, so you see that they make a line, constant rate of change. The other thing that I want to point out is you can have fractional decimal values. It's way okay. And actually, it is a better representation of the solution. So I still graphed those. And those values make it true. So when I substituted 0.5 in for, if 0.5 was x, 5.5 had to be what y would be to make it true. So these are solutions. We graph them. And that's, again, why we have this continuous line that's going on here. And same way on the second one, when I had 1.5 and 3, this was a point on my graph. It's a solution. And we can certainly have fraction and decimal solutions because they are part of the solution set, part of the graph. So hopefully this helps us draw connections between the table, the equation, and the graph, and solutions. We are given an equation. We find combinations of x's and y's, unique combinations that make that true if we substitute in. And then we graph those points, and we draw the line to represent all the solutions that are here. So hopefully that helps you draw connections and provide you some feedback as well.